Hello, today we're going to be discussing relationships and in particular relationships with graphs. So just to start off, I like to start with this graph where we actually have two lines, right? And they almost appear to be doing the same thing as time goes on, right? So this goes back to 400,000 years before the present, and present is the zero here. The blue line represents carbon dioxide, and the red line represents the temperature at that time. So there's a couple ways that we can analyze this data. The first thing we can notice is that there is a direct relationship between carbon dioxide and temperature, meaning that as the carbon dioxide levels rise, the temperatures rise as well. As the carbon dioxide temperatures fall, as the carbon dioxide levels fall, the temperatures fall, right? But there's another way to look at this. We can look at temperature and carbon dioxide over time. So you'll notice that they go down, and they come back up, and down, and back up, and down, and back up, and down, and back up, which is a cyclic relationship. So that's what we're going to be focusing on today, is going to be stating the types of relationships that we see. And there's four types of relationships: direct, indirect, constant, and cyclic. To start with direct is going to be when two things are either increasing together or when two things are either decreasing together. So some examples that I'm going to give you are: the more food you eat, the fuller your stomach becomes. Meaning that as the food you eat increases, the fullness that you feel also increases, right? Another example is as the angle of the sun increases in the sky, the temperature outside increases as well. So the higher the sun gets, the warmer it is outside. So a direct relationship is as one thing increases, the other thing increases as well. An increase and an increase is a direct relationship. This is a direct relationship. We have mass on the left side and we have volume on the x-axis. So mass on the y-axis, volume on the x-axis. As you can see, when we have a mass of 100, the volume is 200. As we increase the volume to as we increase the mass to 200, the volume increases to 400. So as mass increases, so does the volume, and that is a direct relationship. And that's what a direct relationship graph looks like. It looks like a line that starts near the bottom left and rises up towards the right. An indirect relationship is the opposite of a direct relationship. As one thing increases, the other thing decreases. So in this case, instead of saying the fullness that you feel when you eat, we're going to use the opposite word of hunger, right? The opposite of hungry is full, the opposite of full is hunger. So the more food you eat, as food increases, your hunger or hungriness becomes less, right? So that is going to be an increase for food, while we have a decrease for hunger. Another example is as the sun increases in the sky and gets higher and higher, the amount of darkness decreases. So indirect is as one thing increases, the other thing decreases. And that graph is going to look like the opposite of a direct relationship. Remember, a direct relationship is one thing increases, the other thing increases. So that line looked like this. The opposite of that is going to be a line that looks like this. It starts on the top left and goes down to the bottom right. That is an indirect relationship. A constant relationship is that as one thing changes and goes on, the other thing does not change at all. So if you're a really good musician and you write songs, the more songs you write, or as the amount of songs you write increases, the quality of the music stays the same. If it's good music, it's good music. It doesn't matter how many songs you write, we're going to have consistent music. Or something that has nothing to do with the other. As your happiness increases, right, the happier you become, your hunger remains the same. It is a constant, so it doesn't change. This graph isn't going to be an up, it isn't going to be a down, it's just going to be a line that comes straight across. All right? Because as something changes, as something goes on, this number doesn't change. It remains constant. And then the final thing is a cyclic relationship. This is going to be data that repeats over and over and over and over. So the temperature from day to day is cyclic, meaning that during the day it gets warm, and then at night it gets cold. And the next day it gets warm, and at night it gets cold. Warm and cold. And that graph looks, as you would expect, like waves. It goes down, then up, then down, then up, then down, then up, then down, then up. And that is a cyclic relationship, okay?